Hello, my name is Scott Mesjian, and today I'll be doing the second explainer video for week 3 for section 8. On your first trip to Planet X, you happen to take along a 200-gram mass, a 40 centimeter long spring, a meter stick, and a stopwatch. You're curious about the free fall acceleration on Planet X, where ordinary tasks seem easier than on Earth, but you can't find this information in your visitor's guide. One night you suspend the spring from the ceiling in your room and hang the mass from it. You find that the mass stretches the string by 31.2 centimeters. You then pull the mass down 10 centimeters and release it. With the stopwatch, you find that 10 oscillations take 14.5 seconds. Based on this information, what is G? So first thing we should do is draw a little diagram of the situation for ourselves. This is going to be our ceiling, and this is the spring when it has no mass. That's going to have a length of 40 centimeters. Now, and this is kind of after, when we attach that mass, it's going to have that 40 centimeters, but then also it's going to get an extra, and I know that that's not proportional, but please bear with my drawing. It's going to go an extra 31.2 centimeters. Additionally, we pull it down 10 centimeters and release it, and then it oscillates back and forth, and it takes 14.5 seconds to go up and down 10 times. So if we think about what that means in terms of a period, well, if it takes 14.5 seconds to do 10 oscillations, then we could easily find the the amount of time for one oscillation. So you just take the time and divide by oh, my lights, sorry about that, the time by the number of oscillations. That gives you the period. So now we have that, and so now let's look at this equation sheet provided by the book, and this is in the back of chapter 15, but let's observe this equation real quickly and notice that um, the, um, the, the the question gives us a lot of information that we could use. It gives us L, 31, and it gives us M. So perhaps we could rewrite this in terms of G to solve to solve for G. Um, so if we do that, we can get triangle, which is change in length times K over M. So now we don't know what the spring constant is, K, but we do notice this equation here. So what if we instead wrote this equation in terms of K and then plugged it into this one? Well, if we do that, let's write out this equation in terms of K. That would just be M over T2 pi squared. Okay, so now let's plug that in to this equation. G is equal to change in L times M over T2 pi squared times M. Well, now something interesting happens. You don't need the mass, even though we were given it. You don't need it. And you just need the change in L and the period. Now, if you plug all those in, sorry to be a little messy here, but the final answer is going to be 5.86 meters per second squared. And notice that that kind of lines up with what it says about the planet, that it's easier than on Earth, tasking easier. So the gravity being lighter on this planet does make sense. And again, some of the tricky things, you cannot forget to convert centimeters into meters. I did that and got around 500, and that was obviously wrong. So please do not forget that. Otherwise, it's just some simple algebraic manipulation for this problem. Nothing too complicated. You just got to know the formulas, and you can get those again from the back of the book in chapter 15, or the back of chapter 15. Sorry. Otherwise, thank you for listening.